Food. According to the United Nations, 1 out of every 8 people on Earth, nearly 1 billion people, suffer from chronic undernourishment. Yet it is admitted that there is enough food produced today by traditional market methods alone to provide everyone in the world with at least 2,720 kilocalories per day, which is more than enough to maintain basic health for most. Therefore, just in principle right now, the existence of such a large-scale number of chronically hungry people reveals at a minimum that there is something fundamentally wrong with the global industrial and economic process. According to the Institution of Mechanical Engineers, quote, "It is estimated that 30 to 50% of all food produced never reaches a human stomach. And this figure does not reflect the fact that large amounts of land, energy, fertilizers, and water have also been lost in the production of foodstuffs, which simply end up as waste." And while there is certainly an imperative to consider the relevance of these waste patterns, it appears that the most effective and practical means to overcome this global deficiency entirely is to update the system of food production itself with the most strategic localization in order to reduce the waste caused by inefficiencies in the current global supply chain. And perhaps the most promising of these arrangements is something called vertical farming, which I assume many are familiar with. Vertical farming has been put to test in a number of regions with extremely promising results regarding efficiency and conservation. This method of abundant food production will not only use less resources per unit output, causing less waste, have a reduced ecological footprint, increase food quality and the like. It will also use less surface of the planet, it uses less land area than we're doing today. It can even be done offshore. It's that versatile, enabling types of food as well that certain climates and regions simply couldn't produce because it's enclosed. A vertical farm system in Singapore, for example, custom-built a transparent enclosure, uses a closed-loop automated hydraulic system to rotate the crops in circles between sunlight and an organic nutrient treatment, costing only about $3 a month in electricity for each enclosure. This system also is reported to have 10 times more productivity per square foot than conventional farming, again, using much less water, labor, and fertilizer. Students at Columbia University in the US determined that in order to feed 50,000 people, a 30-story farm built on the size of a basic city block would be needed, which is about 6.4 acres. If we extrapolate this in the context of the city of Los Angeles, California, where I'm coming from, with a population of about 4 million, with a total acreage of about 318,000, it would take roughly 78 structures to feed all residents. This amounts to about 0.1% of the total land area of Los Angeles to feed the entire population. If we apply this extrapolation to the Earth and the human population of 7.2 billion, we end up needing about 144,000 vertical farms to feed the whole world. This amounts to about 921,000 acres of land to place these farms, which, given about 38% of the Earth's land is currently being used for traditional agriculture, we find that we only need about 0.006% of the Earth's existing agricultural land to meet production requirements. Of course, let's be a little bit more consistent. Within that 38% land use statistic for agriculture, much of that land is also used for livestock cultivation, not just crop cultivation. So, if we were to theoretically take only the crop production land currently being used, which is about 4 billion acres, replacing land-based cultivation by dropping these 30-story vertical farms side by side in theory, the food output would be enough to meet the nutritional needs to feed 34.4 trillion people. Given that we only need to feed about 9 billion by 2050, we only need to harness about 0.02% of this theoretical capacity, which, it could be argued, makes rather moot any seemingly practical objections common to the aforementioned extrapolation. In short, we have absolute global food abundance potential.